Hi everyone, today we will talk about a very famous and interesting Google interview question. Allocate minimum number of pages. So let's first understand the problem statement. What we have given is we have given set of books, okay? And these are the number of pages each book has. For example, book 1 has 10 pages, book 2 has 20 pages, and book 3 has 30 pages, and book 4 has 40 pages. And now we have also given the number of students. We have only two students. Now what's the expected outcome of this question is we have to minimize the maximum number of pages that a student can read. Basically, we don't want to stress out the students. We want to minimize the number of pages that a student these students will have to read. For example, let me pick. For example, 10, 20, 30, 40. These are the pages of books, right? And now there are three more constraints given in this question is first is each student basically first thing is we have to allocate the books in a continuous manner. We cannot allocate book 1 to student 1 and uh, book 1 and 3 to student 1 and 2 and 4 to student 2. It should be either 10 20, 10 20 30, or 10 20 30 40. Okay, if there is a one student. So books should be allocated in a continuous manner. And second constraint is at least each student must have allocated a book allocated. So, for example, there are two students, right? So, it's like we cannot allocate all the books to student one, and we cannot basically leave student two as free, or like if there are more than two students, right? We cannot basically stress out specific students, and other students should not be set free. So we must allocate books to each student. Okay, and third constraint is we cannot allocate the books partially. Partial allocation is not allowed. For example, you cannot, so if book one, so if you see book one has 10 pages and you cannot allocate like this book, student one can read 5 pages and student two can read 5 pages. This is not allowed. So each book has to be allocated to fully to one student only. So these are the three constraints. Okay. So keeping these three constraints in mind, let's do the allocation now. For example, uh, if we give book 1 to student 1, okay, this is my student 1 and this is my student 2. If we give book 1 to student 1 and the remaining book to student 2, that will be 90, right? 30 plus 30, 20 plus 30 plus 40. Now, uh, next, basically we are finding all the permutation combination which are possible. Now, if we allocate book 1 and book 2 to student 1, 20 plus 10, right? 30. And these two to student 2, 30 plus 40 is 70. Because books can be allocated only in continuous manner. That is the reason I'm allocating one by like first I allocate 10, then 20, 20, then next I'll allocate 10, 20, 30. Okay. So next is 10 plus 20 plus 30, which is 60, and next remaining is 40. Now I cannot do this like this 10 20 30 40, because then in that way a student will one will have all the books and student 2 will not have anything, right? Then student 1 will be stressed out, so that is not allowed as per condition 2, right? So now these are the possible combinations which we have. Now maximum number of pages student can read from the first permutation is 90, right? Because student 1 is reading 10 pages and student 2 is reading 90 pages. So maximum is 90, right? Now 30 and 70. So maximum again student 2 is reading is the 70 pages. And third combination we have is now here student 1 is reading the maximum, which is 60 pages. Okay, so these are the possible choices we have. Now we don't want to stress out the students, so we want to minimize the number of pages that minimize the maximum number of pages that a student can read. So minimum out of these three choices is 60, right? So 60 is our answer. Okay, so now let's see how we can solve this programmatically. Okay, so these are the numbers. What we are looking for is the optimal cut, right? Uh, can we allocate book 1 to student 1 and remaining to student 2, or can we allocate 10 and 20 to student 1 and 30 and 40 to student 2? We are looking for the optimal choice here. Basically, we have to search for a optimal number, right? So we'll be solving this using the binary search. So this is quite hard to discuss the quite hard to guess that it can be solved using binary search. But believe me, once you have done this question, right? So next time whenever this type of question comes, you will like definitely think about using a binary search in this such scenario. Okay, so now we have to see how we can solve this using binary search. Let me clear some area. Okay, the numbers we have is 10, 20, 30, 40. Okay, now maximum number of pages which we have is 100, right? 10, 20, 30, 40. And minimum number of pages, I'm just writing 0 here, just so that I can explain better. But in when we do the code, when we write the code, right, we have to handle this condition because it specifically mentioned that uh, at least a book should be allocated to a student, right? So it allocation cannot be 0. Okay, so we have maximum number of pages 100 and minimum number of pages 0. So what we do in binary search is basically we have a concept of using the mid, right? So I'm not able to write. Yeah, so mid of this is 50, correct? So 50, think of 50 like this, that you are setting the criteria that maximum number of pages which you can allocate should not be more than 50. Okay, for example, student 1, right? We pick from array. So we pick from array 10. 10, we are saying that maximum we can allocate is 50. So 10 is fine, right? We can give to student 1. Student 1. Now next is 20. 10 plus 20 is 30. 30 is again less than 50. So which is still allowed, right? Because maximum we are saying is maximum you can allocate 50 to a student. Now 20 is 30, right? 30 less than 50. Okay. So now again if we move ahead 10, 20, 30. So which will be 60, right? 60 is greater than 50, but we said that maximum allowed is 50, so we will definitely not consider this and we will allocate the 30 to next student. Okay, so only these two will we will allocate to student 1. So now 30 we have allocated to student 2. Now we will move ahead 30 plus 40, 70, right? 70 is again not less than 50. So definitely we cannot allocate 40 to student 2. If there are more students, we can allocate 40 to that student, but not to S2 because maximum allowed is 50. That means, but in the question, maximum students mentioned are 2, right? But if we give 50 maximum pages to each student, then this cannot be solved, right? Because we need more students. So then definitely we have to increase the load on the students. If both the students read 50-50, then we cannot complete the books, right? So we definitely will have to increase the load on the students, like they will have to read more pages because there are only two students, so they have to read more pages. That means we have to move on the right side. Okay, so now again we will do this exercise. 50 and 100, mid is 75. Mid is 75. Now we are saying, okay, we have two students, fine. Maximum pages that a student will have to read is 75. Now let's see. Student 1 comes 10. Yes, it's less than 75. We can allocate more pages. 20, fine. 30, we can, 30 is less than 75, right? So we can allocate more pages to student 1. Now 10 plus 20 plus 30, right? 30, 50, 60, right? So 60 less than 75. Cool. We can allocate more pages. Now 60 plus 40, 100, right? 100 is not uh, less than 75. So definitely we cannot allocate 40 to student 1. Now 40 we will allocate to student 2 and 60 we will allocate to student 1. So, okay, so this is fine. This is one of the option that if we can, if we set that maximum pages a student can read is 75, then it's feasible, right? It looks feasible. We can, student 1 can read this set of pages and student 2 can read this set of pages. But what we are saying is the ask from this question is to minimize the number of pages that a student can read, right? So 75, we are saying, okay, 75 is fine. It's good. We can allocate, but can we reduce the stress of student further? Can we try if we can minimize this? Okay. So next what we have to do is, if it's a valid solution, if it's a valid answer, then we have to try to minimize that number. Okay. We will move on that left side because we want to minimize. Cool. Now what we have to do is again we will calculate the mid. So 50, 75, mid is, so mid we calculate like this, right? Start plus end by 2. It's 125, right? By 2, and this is 62. 62 is our mid. Now we want to try if we allocate uh, maximum number of, if we set maximum number of pages 62, is that allocation possible? Okay, let's try. To student 1 we allocate 10. Okay, fine. 10 is less than 60, we can allocate more. 20 can 30, 30 less than 62, right? We can allocate more. 30, 20, 50, 60, right? 60 less than 62. Okay, fine. We can allocate this. Now when we add 20, 30 plus 40, it's not less than 62, right? We cannot do this, and we will allocate 40 to student 2. Okay, so this allocation seems possible, right? So we can set maximum number of pages to 62. Okay, again coming back on the same point, what we said was like this answer is fine, but we have to see if can we further minimize, because we want the best for our student, right? We don't want to stress them out. So can we reduce this number of pages that a student can read? So now again we will calculate mid. 50 plus 62 divide by 2, right? Then it is 1 1 2 5 6 56, right? Again mid will be 56, and we will do the same exercise, and we'll see if, okay, let me, I don't have space. Let me erase some of the stuff. Cool. We tried for 62. Now we want to try, can we allocate 56? Okay. So let's see. Now student 1 will 10 plus 20, it's allowed 30, right? 30 is less than 56. Again, we allocate 30 more pages, which is again less than 30, 50, 60, right? Which is not less than 56. So definitely we'll have to allocate more pages. So we allocate 10 plus 20 to student 1, 30, right? When we added third number 30, it was like 60, but maximum allowed is 56. So definitely we'll have to allocate 30 to student 1. Okay, student 2. So now 30 is less than 56, fine. We can allocate more, 30 plus 40, not less than 56, right? It's 70. So definitely it we cannot allocate 56 pages. We have to increase the number of pages. We have to basically give more work to the students because we cannot allocate, we are not able to allocate fully. Again, we will calculate the mid. 56 plus 62 by 2, right? 8 and 11 to 5, 60, right? So next is 60 is our mid. Okay, so let's see now. Mid is 60, and again we'll do the same exercise. 10 we allocated to student 1, student 2 we allocated 20, 30 is less than 60. We can allocate more, and when we added 30, 10 plus 20 plus 30, 30 plus 20, 50 plus 10, 60, right? So it's less than equal to 60, fine. And again we allocated remaining to student to 40. So when we took the mid 60, right, but we were not able to move like with the 60 we are able to allocate fully. So now we cannot further uh, find that do the same exercise, right? Because we are almost calculated this also 62 and 60. So so we have couple of solutions here, right? 70, 60, and what we uh, calculated first was 90. So out of these minimum is 60. So that's how we will be solving this using binary search. Okay, let me jump to the code. Okay, and one more thing here is so we have given the maximum number of students, right? Two, and we have given four books. So let's say if students are five and books are four, definitely there is no way we can allocate five books to four students, right? Because we need at least one more book. So that should be the base, starting condition. So if books are more than if number of students are more than books, if students are greater than books, right? We have to return -1 because partial allocation is not allowed and it will not work. Okay, so yep, so this is my main method, find number of pages. Let me first run this. So these are the number of books and maximum number of students are 2. So if you see, answer is 60. That's what we calculated manually, right? So find pages is the method, and start I told you, right? We cannot at least one page, one book we have to allocate to at least one student. We cannot basically spare any student. So this one book we have to choose from these available books, and we will be giving the book which has maximum number of pages to start with. Okay, so I have written a find max method. So find max is just calculating whatever is the maximum. So for example, 10, 20, 30, 40, and 40 is the maximum. So my start will be 40 and my end will be the sum. So sum will be, I used 100 here, right? Which is the sum of all the pages. Okay. And this is a simple binary search. Okay. While start less than end will keep on going, and mid we will be calculating. Let me open this side by side. Okay, so mid we are calculating, every time we are calculating mid, right? Mid is start plus end by 2. And just to avoid integer overflow, can you start plus n minus start by 2. And now when we have mid, right, post that we are checking if allocation is possible with this mid, with this number. Like mid is nothing but the maximum number of pages which we are allocating, right? So if allocation is not possible, is valid is the method which basically is checking if allocation is possible. So if allocation is possible, we will further try to minimize this, right? If let's say allocation is possible, again we are going on the left side. We want to reduce the stress on student. So even if we got the solution allocation is possible, we are saying if can we further reduce it. So if we want to like we want to check if we can reduce it, right? So that's the reason we are going on left side. So once we are going on left side, so our end will be changed to mid minus 1. Okay, and we are storing that result. And if allocation is not possible, so we will be incrementing, we'll be setting start as mid plus 1. Okay, now next let's check what how we are basically checking if the allocation is possible. So this is really simple. So how we were doing manually was, like we were just adding these numbers one by one, right? So like first we picked 10 and then we added 20, 30, right? 30 less than this mid, this target, and again we will keep on adding more numbers to this. That's what this for loop is doing. Simply, um, this is the target. Target is basically there we are passing the mid. Okay. So here what we are checking, one by one we are adding the numbers into sum so far. And if that sum is greater than target, if let's say we allocated 50 and again when we add 30, then sum will be 10, 20, 30, it will be 60, right? We cannot, it's crossing the target number 50. So definitely we have to increase the number of students here, that 30 will should be allocated to next student. So that's what I'm doing here. I'm just incrementing the students plus plus, that if my sum is crossed my target, then I will have to add more students. Okay, and some I am resetting. Some basically now new student we were starting from the n- this, so this 30 number, right? We were allocating to student 2. So that's what this is doing. And now one more optimization is, let's say you have two students, okay, and the so you remember when we first allocated 50, we set when we first set the 50 as the target number, so there was need to add more student as 3, but maximum allowed students were 2. So that's the this condition. If maximum allowed, if the students are greater than maximum allowed student, then we will just simply return false from here, else return true. Okay, so that's pretty much it. I hope you understood this question. If you liked my video, please give me thumbs up and also let me know your feedback in the comment section. And also, if you want to see more such Google interview questions, please subscribe my channel. Thank you. Thanks for watching.